Hello guys, so we will start with communication system. So what we will do is we'll see some of the formulas in communication system amplitude modulator first, and then we will solve some questions based on amplitude modulation. Alright, so let us consider my message signal is AM cos 2 pi FM of t, where AM is message signal amplitude and FM is message signal frequency. The carrier signal is C of t, which is equal to AC cos 2 pi FC of t, where AC is amplitude of carrier signal and FC is carrier signal frequency. So the modulated signal of modulated signal will be AC into 1 plus Ka into m of t cos 2 pi FCT. As you know, this Ka will be my sensitivity, right? So sensitivity of modulator is Ka. Now if you try to put this m of t is equal to am cos 2 pi fmt, then am into k will become mu, that is modulation index. So my modulated signal, amplitude modulated signal s of t will become AC into 1 plus mu cos 2 pi fm of t into cos 2 pi fct. So try to understand and put it in your mind this particular a structure of amplitude modulated signal. Okay, this is how you will recognize the amplitude modulation. So what is happening here? My modulation index mu is nothing but the modulation sensitivity Ka into message signal amplitude m of t. Alright. Now we will try to understand what is my total power of amplitude modulator. So the total power of amplitude modulator, I am not going to derive it as it is already derived in our theory class. So this will be equal to Pc into 1 plus mu square by 2. Alright. This can be generalized for multitone signal as well. Here modulation index mu will become mu t. Okay, the total modulation index. Alright. So Pc is nothing but the carrier power, which can be also derived from your carrier signal, which will be equal to AC square by 2. So as you can see, the total power is nothing but the sum of carrier power plus sum of sideband powers. Okay, so the sideband power is remaining power, which is Pc into mu square by 2. So the sideband power is nothing but Pc into mu square by 2. So that you have to understand. The sideband actually carries both upper sideband as well as lower sideband. So P USB plus P LSB, that is going to be your PSB. And since LSB and USB both will be half, so I can write down my PUSB is equal to PLSB. It is going to be half of this sideband, that is Pc into mu square by 4. So this is another formula. Alright. The bandwidth requirement would be, so as you know, let's say this is my FC, this is my FC plus FM, this is my FC minus FM. Same way here also it will become minus FC, and this will be minus of FC minus FM, and this will be minus of FC plus FM. This is your 0. So if you see, the bandwidth requirement is the maximum frequency minus minimum frequency. So bandwidth will be FC plus FM minus FC minus FM, that is going to be 2 FM. Alright. So this is the total bandwidth that is required in amplitude modulator. Alright. Next is, let us say we have multitone signal. So the multitone signal, like, it means the message signal is having multiple frequencies, like let's say AM1 cos 2 pi FM1 of t. Okay, so this is first message signal with another message signal is AM2 cos 2 pi FM2 of t. So basically we have AM1 another one signal with frequency FM1, AM2 another amplitude with frequency FM2. So these are the thing. So in that case, your total modulation index mu square will become mu1 square plus mu2 square, or I'll write it as mu t. Mu t total is equal to mu1 square plus mu2 square, and if you want to find out mu t, that is going to be a square root of mu1 square plus mu2 square. So in that case, your PC, your total power of modulated signal, amplitude modulated signal, will become Pc into 1 plus mu t square by 2. So you can remember same mu square by 2, where mu is nothing but the total modulation index. Alright. The bandwidth requirement will become 2 times Fm max. Why max? Because it may be possible that Fm1 is more than Fm2, so Fc plus Fm1 will be higher than Fc plus Fm2, or Fm2 is more than Fc plus Fm2 will be higher than Fc plus Fm1. Okay, so whichever is maximum frequency that is available in message signal, that times multiplied by 2 is your total bandwidth requirement. All right. Next, let us relate my amplitude modulated envelope with modulation index. So let's say this is my A max, and let's say this is my A mean. Okay. So this is how we are going to find out. So as you can see, my modulated signal was AC into 1 plus mu cos 2 pi fmt into cos 2 pi fct. So you know cos theta is maximum is 1 and cos theta minimum is minus 1. So from that, the maximum of this will be how much? A max, that will be AC into 1 plus mu, and the minimum is AC into 1 minus mu. So with this, if I want to find out what is my AC in terms of A max and A mean of modulated signal, this is my amplitude modulated signal. So my AC will become how much? If you add them together, mu will get cancelled. So A max plus A mean divided by 2. Similarly, if you try to find out what is your mu from here, so mu will become A max minus A mean divided by, see, if you subtract A max minus A mean divided by AC, 2AC will come, so 2AC will become A max plus A mean. So this is very important formula for your modulation index. Alright. Now if you want to find out what is your efficiency, so efficiency is nothing but what is your power available in your sideband divided by what is your total power. Okay, so this is one formula that you can utilize, and you know already, if I want to derive it, so eta will become PSB, that is total sideband power is PC into mu square by 2, just now I told you, into PC into 1 plus mu square by 2. So this will get cancelled. So from here you are going to get mu eta is equal to mu square by 2 plus mu square. So this is another formula for your eta. Alright. Now it is very important to understand in terms of carrier current and carrier voltage, because carrier signals is having, you know, like amplitude, so that can carry a voltage as well as current. So you know the power is in terms of voltage is V square by R, and it can be written as I square into R. So for unity it can be written as V square is equal to I square. Okay, so from there you have the total power of amplitude modulator is PC into 1 plus mu square by 2. So if you try to put your voltage, so total voltage of your modulated signal will become voltage square of carrier signal into 1 plus mu square by 2. So this is very important formula in terms of voltage of the signal. Similarly, the total carrier current of modulated signal will be equal to IT square is equal to the total current, carrier current square into 1 plus mu square by 2. So this is how you have related your total total current that is available in your modulated signal in terms of the modulation index as well as the carrier current available in the carrier signal. So alright guys, so with this these formulas we will try to utilize in our upcoming questions, and it will be very easy for you to, you know, like go through the previous year GATE questions related to all amplitude modulations. Alright guys, so please stay tuned and we'll solve some questions based on this. Thank you.